Welcome back. In this video, you will learn about some AWS services you can use to store and visualize unstructured data. Structured data is organized in a defined scheme. An employee record with a defined set of fields is an example of structured data. In addition to a set of fields, schemas specify the type of data allowed in those fields. You can think of structured data as data you'd store in a traditional database management system that supports structured query language or SQL. Unstructured data doesn't follow a set of schema. Some records might have 4 fields and others might have 14 fields. Unstructured data could include many different data types, such as text, numeric, or even binary objects. Many NLP datasets are unstructured. You'll learn about 3 AWS services you can use to store unstructured data. Amazon Simple Storage Service, or Amazon S3, offers virtually unlimited storage. The storage capacity and high reliability of S3 makes it a good storage solution for most NLP applications. You can use S3 to store both structured and unstructured data for ML solutions. Structured data for traditional database applications will usually use another storage solution such as Amazon Relational Database Service or Amazon RDS. Search-based applications pool data together across large datasets to surface information. You can build complex search applications with Amazon Elasticsearch Service or Amazon ES. The service is tightly integrated with Kibana, an open-source visualization system. Most search-based applications depend on highly dynamic data, which means you need a way to update that data in near real time. Amazon ES is also integrated with services like Amazon Kinesis and Data Streams and Amazon DynamoDB to address the need for near continuous updates to data. Knowledge graphs are a special form of search-based application. In 2012, Google launched one of the first commercial knowledge graphs to help customers see results for a specific context. Amazon Neptune provides a database service that's designed to work with commonly used graph models. Neptune provides automated backup to S3. When you set up a Neptune cluster, you can include read replicas, which provide higher performance for read-intensive applications. Amazon S3 is the most commonly used storage service for ML applications. Amazon S3 is used as a storage system for many Amazon SageMaker deployments. Though S3 is sufficient for many NLP applications, it might not be appropriate for the scenarios that require high-performance searches over large data sets. Search applications are one of the most common forms of NLP problems. Returning meaningful search results require the application to understand the context of the search. For example, searching for the word apple without any knowledge of context might return records for a computer company, a fruit, and a music label. Although search applications are becoming very common, here are 3 common examples. The first example is an application that shows text data as a time series. For example, it might display customer reviews for a product over time. The second example is the visualization of relationships in a collection of text data. One example of this would be a word cloud of common terms and a collection of scientific journal articles. Finally, the third example of a search application is a combination of search with an NLP interface. For example, now this could be a bot based on searching documents or images. All database systems have some capability to model relationships. Graph databases, however, are better at dealing with data sets where the relationships are complex or where they might not be fully understood in the design stage. With the rapid expansion of data in the era of cloud computing, graph databases have emerged as a way to explore relationships and acquire new knowledge and insights. Here are a few examples of how Amazon Neptune has been used to do this. First, Neptune has been used for navigation tools. Examples include researchers looking for connections between scientific papers and recommendation engines. Neptune has also been used to provide visual representation of data. Examples of this include employment and occupational trends for human resources planning, fraud detection, and analyzing network traffic. Finally, Neptune has been used for geographic visualizations. Some examples include global operations for a multinational company, and building shopping applications based on GPS data. In this section, you learned about the differences between structured and unstructured data. You also learned about 3 different AWS services used for storing data for NLP problems. The first service was Amazon S3, which is integrated with many Amazon machine learning services. S3 provides virtually unlimited object storage and 11 nines of reliability. Amazon ES is a managed service you can use to build applications that require complex search patterns. You can build search applications with both static and streaming data. Finally, you learned about Neptune, which is designed to support applications based on graph databases. Graph databases treat relationships between data as important as the data itself. They are especially useful for data with complex relationships, or even relationships that are unknown in the design and development stage. Thanks for completing this module. In the next module, you'll learn how to implement sentiment analysis. See you in the next video.
Hi, and welcome to Module 4, Implementing Sentiment Analysis. Here's what you'll learn about in this module. In the first section, you'll learn about the scenario you'll use in this module and the lab. In Section 2, you'll examine the processing steps typically used in sentiment analysis and determine which steps might be useful for the scenario. The third section reviews some of the algorithms you could use to solve this problem. You'll also look at what fully managed services can do in this business scenario. Okay, it's time to get started. At the end of this module, you should be able to describe the challenges in working with social media data, evaluate algorithms used for machine learning or ML, and tools used for sentiment analysis in natural language processing or NLP. And finally, you'll create a solution to a sentiment analysis business problem. In this section, you'll get an overview of the scenario. To help apply the techniques you learned in previous modules, you'll work through a small, typical sentiment analysis use case. You'll play the role of a data scientist on a small development team. The organization you work for maintains a website of movie reviews. A key customer feature has been identified. Customers want the website to provide an overall positive or negative score for a particular movie based on the number of positive and negative reviews. You'll develop an ML solution that allows developers to create an inference for a movie review. You'll need to analyze the review and indicate if it's positive or negative. To help with this task, you have access to a data set that contains the raw text of 50,000 movie reviews. These reviews have been labeled either as positive or negative. In the example, the data set consists of 2 columns. The first is the text column, which contains the raw text of the movie review. The sentiment column contains a 1 if the review is positive and a 0 if the review is negative. The dataset doesn't include any identifying information about the actual movie. Thanks for watching. In the next video, you'll identify the text processing steps for this business problem. Welcome back. In this video, you'll continue to work on the video rating problem. The business problem you're working on seems to be a supervised binary classification problem because you can use a labeled dataset for this problem, which means that it's supervised. Also, the problem has 2 values to be predicted, that is positive or negative, which means that it's a binary classification problem. For the first step, you're working with a labeled dataset, and it needs to be in a form that's useful to a machine learning model. So you need to decide what normalization tasks you'll use to get the text data into the form the ML model needs. After you normalize and clean the text, you need to transform the text into numerical values. These numerical values can be either new features or feature vectors. Whether you choose to use new features or feature vectors mostly depends on the requirements of the algorithm you select. When the data is ready, you need to split the data. You'll split the data into a training set, a test set, and depending on the algorithm, you might also create a validation set. You'll use this data to train a classifier. When you train the model, it's important to use metrics so you can determine how well the model performed. You could try a few different models to find the best one for your data, and you might need to tune the models as you go. Given the typical example on the slide, what processing steps could you take? Take a few minutes to think about the appropriate steps. Movie reviews on a website usually aren't written by a trained linguist with 20 years of industry experience. Reviews often contain a variety of informal elements that you'll need to handle. These elements could include markup, such as HTML, emojis, abbreviations or shortcuts, such as we're for we are, and URLs or web addresses. The elements you must handle also include word spacing. For example, is there more than one space between words? The text could also include non-standard or incorrect spelling, or have incorrect grammar or punctuation. The text could also have multilingual language, because some people use multiple language when they write on social media or review sites. Or the text could use transliteration, which is where a word from one language is written phonetically in another language, usually with Roman script. For example, at a Chinese restaurant, the menu might include the name of a dish in Chinese characters as well as a phonetic English spelling of the name. Finally, the text could include homonyms, which are words with multiple meanings. For example, consider these three sentences. You are right. Take a right after the bus stop. And water is a basic human right. They all use the word right, but right has a different meaning in each sentence. You also need to consider how to handle sarcasm in the movie review text. In broader business problems, you might also encounter trolls, memes, slang, and fake news. Text length could also be an issue for processing social media text because it tends to be shorter than a manuscript or book. For handling special cases like short social media text, look for a pre-trained model. As an example, consider the Natural Language Toolkit, or NLTK. It's a Python library that has a tweet tokenizer, which can be useful for processing tweets. Consider all of these elements in your business problem. However, not all the elements in your data need to be addressed. You'll need to experiment to see what works for your business case. Some of the processing tasks are straightforward, such as removing markup. Other tasks, like transliteration, can be complex to handle. For this movie review dataset, you'll most likely do these processing steps. First, you'll clean up the text. In this step, you'll convert all text to lowercase. You'll also remove spaces, HTML tags, and other formatting anomalies. Next, you'll remove stop words, but be careful here. Remember that removing words used for negating statements, such as not, could have an impact on when you need to predict sentiment. And finally, you'll tokenize or vectorize the text, depending on the algorithms you use. You might use a simple tokenizer for bag of words, or BOW, or you might create vectors using word2vec. Handling missing values presents an interesting set of choices in machine learning. Generally, if the data is missing a few text values, you might want to drop the rows. Whether you drop the rows depends on the amount of data you have. You'll usually want to avoid having some features with missing data unless you have many other features you can use. Filling in missing values with similar rows could be risky, but whether you do so depends on the problem you're trying to solve. For other missing values, inputting the values using standard ML techniques is a valid option. In this section, you learned about the machine learning steps. You mapped a typical ML workflow to the business problem and identified the key steps. You also looked at some of the challenges with handling informal text data, such as reviews or social media. Next, you identified the steps you'll take in the lab later in this module. And finally, you considered how to handle missing text data. Thanks for watching. In the next video, you'll examine algorithms for sentiment analysis. Welcome back. In this video, you look at the algorithms for sentiment analysis. In the previous section, you learned that the business problem could be solved as a supervised binary classification problem. Now you need to decide which metrics to use to evaluate the model. You want to know how well both positive and negative reviews are predicted. Perhaps error or accuracy are appropriate metrics. What other metrics might you consider? Whatever you decide, be consistent across different algorithms and services to ensure you're comparing the performance accurately. One problem you might come across is class imbalance. This occurs when the samples you have are not equally distributed. For example, in fraud detection, you typically have a high percentage of non-fraudulent transactions and only a few fraudulent ones. As an example, it's worth noting that the number of 5-star reviews in the Amazon customer reviews dataset is almost equal to the total number of the other 4 types of star reviews combined. An ML model might not work well for infrequent classes. Consult the algorithm documentation to see if this is true for the algorithms you're considering. You will look at how to address this in the next slide. You can use a few techniques to handle the class imbalance problem. The first is downsampling. With this technique, you reduce the number of dominant classes so the mix is more balanced. You can also use upsampling. This is where you increase the size of the small classes to match the larger class. A third technique is to use data generation tools to create new records based on existing ones. An example from image processing is to rotate an image slightly. Finally, for a model that uses a cost function, you can use the sample weights technique to assign higher weights to rarer classes. To make things easier in this module, you will find that the movie review dataset does not have any class imbalance. Keep a couple of other things in mind. First, when you transform text data into a numerical representation, you can end up with sparse vectors. A sparse vector has a large number of zeros. You might need to consider how these largely empty vectors are stored and processed. It's often useful to store only the non-zero data, but the trade-off is that accessing the data becomes more complex. Check with the algorithm you're using to see if sparse vectors could cause issues. XGBoost, which you use in the lab, tends to do well with sparse data, again to make things easier in the lab. Second, you can use hyperparameter tuning to get better or sometimes worse results from the algorithm. Set aside time to tune your model, which can improve results. Each algorithm has a set of hyperparameters that you can adjust. The documentation usually has tips on which hyperparameters have the most impact and what the ranges are. To tune hyperparameters, you create a hyperparameter tuning job and use the model's metrics to evaluate the best model. You'll get to try this in the lab. XGBoost is a popular and efficient open source implementation of the gradient boosted trees algorithm. Gradient boosting is a supervised learning algorithm that attempts to accurately predict a target variable. To get a prediction, the algorithm combines estimates from a set of simpler, weaker models. XGBoost has performed well in ML competitions. It robustly handles various data types, relationships, and distributions. It can also handle the many hyperparameters that you can tweak and tune for improved fit. This flexibility makes XGBoost a solid choice for problems in regression, classification, both binary and multi-class, and ranking. Blazing Text implements word-to-vec, and it can also perform text classification. This works well for sentiment analysis, spam detection, and hashtag prediction. The required data format is straightforward. It requires the label, the 0 or 1 from the sentiment column, to be preceded with a tag of _, label _. The text should follow this tag, with each record on a single line. When training the classifier for smaller datasets, meaning 2 GB or less, a C5 instance works well. For larger datasets, consider using a GPU instance, such as an ML.P2 or ML.P3 for performance. Note that after the model is trained, you can run it on a smaller instance. As well as training your own model, you can use a pre-trained model. This can be a good starting point to see what sort of results you get. The NLTK contains a BOW implementation named Vader Lexicon. TextBlob also uses a BOW classifier, but it also includes subjectivity analysis. Subjective sentences generally refer to personal opinions, emotions, or judgments, whereas objective sentences refer to factual information. FLAIR is based on a character-level long short-term memory, or LSTM, neural network. It factors in sequences of letters and words, which means it can handle out-of-vocabulary words, also called OOV words. Amazon Comprehend is a fully managed service for finding insights and relationships in text. It includes an application programming interface, or API, for sentiment analysis, which you can use without any ML knowledge. You pass the API some text and receive a response that includes whether the sentiment is positive, negative, mixed, or neutral. If the default results are not suitable, you can train a custom classifier. You need both testing and training data for this, the same way you would for XGBoost. You need to manipulate the data into the correct format to train the model. Once you've trained the model, you can perform predictions, which return the predicted class and the probability score. In this section, you learned about the type of ML problem the movie sentiment analysis problem represents, how class imbalance could cause issues with certain algorithms and options for dealing with imbalance, 2 built-in Amazon SageMaker algorithms, XGBoost and Blazing Text, using other pre-trained models, and using Amazon Comprehend. Thanks for watching. In the next module, you'll learn about extracting information. See you in the next video.
Hi, and welcome to Module 5, Introducing Information Extraction. In this module, you'll learn about what information extraction is and typical use cases for it, types of information extraction and the problems they can help you solve, and AWS services and open source tools that you can use for information extraction. This module also includes 2 guided labs. In the first lab, you will use Amazon Comprehend and Spacy to extract information from text. In the second lab, you will extract specific entities. Okay, it's time to get started. At the end of this module, you should be able to understand the terms used in information extraction, describe the steps for information extraction, implement key phrase extraction, or KPE, and finally, extract entities from text. In this section, you learn about a few common uses of information extraction. Information extraction is also known as IE. IE is the task of extracting information from text during natural language processing, or NLP. With structured data in a database, IE can be simple because column names often label the data for you, such as name, address, and telephone number. With text, the data is unstructured, so you need different ways to extract the information. Tags that describe Amazon.com product reviews are an example of IE. Information extraction is used to extract key phrases from the reviews to create tags to help customers find reviews that are relevant to their needs. In the next few slides, you'll review a few key applications for IE. The first example is a digital assistant. The assistant must understand the question to be able to form a response. For example, if you ask, "Where is the nearest coffee shop?" The digital assistant needs to understand that coffee shop is a location. The assistant must also understand that you need the shop nearest to your current location, and most likely, the assistant requires the address from the where statement. IE helps to extract the useful information from the sentence so that the digital assistant can act on the information. Identifying common themes in product reviews is another common use case. As the example shows, when a customer researches a product with many reviews, important phrases can help them filter out the reviews they want to read. Tagging news topics is another application. IE can extract names, events, and locations from news articles to help identify trends or highlight important entities. IE can also identify financial data and reports. Key performance metrics, people, events, and relationships are all types of useful information to extract from financial results data. For example, a financial services organization might use an information extraction application to assemble data from a broad set of financial reports. You can also use IE to extract events from data. An event can be anything that happens at a certain point in time, such as a meeting, election, stock price exchange, birth, or job promotion. In the first example, the promotion is the detected event. The detected event could also have been promotion to manager. In the second example, events are detected in an email. Many email systems use temporal information, such as time and location, to identify events from emails and generate calendar reminders or actions based on the extracted information. In this section, you looked at what information extraction is and key applications of it. IE applications include digital assistants that extract information to understand a question, identifying common phrases or themes in product reviews, tagging news topics, identifying financial data in reports, and extracting event information from emails. In the next video, you learn about different types of information extraction. Thanks for watching. Welcome to Section 2. In this section, you look at different types of information extraction, also known as IE. This module provides information about 5 different types of information extraction. The first is key phrase extraction, also known as KPE. KPE extracts useful words or phrases from text. Next is named entity recognition, or NER. NER identifies entities, such as names of people, locations, organizations, dates, and product names. The third is named entity disambiguation, or NED. NED is the task of uniquely identifying entities in text. Then there's relationship extraction, which deals with identifying relationships between entities. Finally, event extraction extracts knowledge about events, such as stock splits or initial public offerings, also known as IPOs. We will start with key phrase extraction, or KPE. KPE extracts useful words and phrases from text. These phrases capture the general intent of the text. KPE is generally an unsupervised machine learning problem. A few algorithms can do KPE. The general approach is to organize the words or phrases into a weighted graph, where the weight indicates the importance of the key phrase. Nodes that are more connected with the rest of the graph are more important. Typically, the top nodes are returned, for example, the top 10 nodes. The Word2Vec visual from Module 3 is an excellent way to visualize this process. That visual used T-distributed stochastic neighbor embedding, also known as TSNE. Term frequency inverse document frequency, or TF-IDF, is a weight that is used to evaluate how important a word is to the document in a corpus. Common words in a document that are not common in the corpus are likely to be important words for that document. KeyBERT is a minimal keyword extraction technique that uses bidirectional encoder representations from transformers, or BERT, embeddings. KeyBERT uses these embeddings to create keywords and key phrases that are most similar to a document. Amazon Comprehend provides an application programming interface, or API, for performing KPE. Another key NLP task is named entity recognition, or NER. NER identifies entities such as people names, locations, organizations, dates, and product names. NER is often required to process downstream tasks. For example, NER can help with event and relationship extraction by extracting event names, locations, and dates. In addition, NER is used in translation to decide if a word needs to be translated. Typical names do not need to be translated. Spacy has an excellent set of tools for extracting and visualizing name entities. You can also use transformers such as BERT. Amazon Comprehend provides an API for entity recognition. You can use this API without machine learning knowledge. The next NLP task is called Name Entity Disambiguation, or NED.